Okay, I think I've completed my task of trying to find a way to turn the circuit on versus off, which can be adapted to pulse width modulation in order to fine-tune the on state by varying how much portion of a duty cycle is it on versus off. Now, off and on are relativistic terms here because it's never entirely off in this format that I'm attempting to implement, but it's pretty close. So what I discovered was that if I put in shorting capacitors and I have them stay outside a range of 1e to the plus 10 farads and 1e to the minus 10 farads, if I'm within that range, the circuit is off. But if I'm outside that range, the circuit is on. The problem going above 1e to the plus 10 farads is that the circuit wants to explode. So I prefer to go below 1e negative 10 farads in order to turn it off. But the only way to not get error messages of matrix is singular, I have to go to extreme low values of 1e to the negative 201 to emulate the lack of a dielectric. So not even a vacuum. In other words, the capacitor plates are separated to the point that you can't even call them a capacitor anymore because the capacitance is so low, it's not even there. So what I envision is two capacitor plates that slide apart and they no longer face each other versus bringing them back into position. So it's not exactly your normal variable capacitor because this is really, I'm using it as an on-off switch. So there's only two states, on versus off. Now they could be spring-loaded to pop open and come back like a ratchet effect or something. I don't know, however, which is the best way. The point is they have to drastically change. Now, changing it is a parametric oscillation, and that might have effects that I can't foresee because I haven't simulated it. But in a static imaginary condition of on versus off, which is not really applicable to rapidly oscillating them, so I really don't know what would happen if I apply this. I still have more work to do on this circuit, obviously. But anyway, at this point in time, I'm able to get pretty good results. So let's see if I move over, if I'm going in the right direction. So now it's not 1e to the minus 201, it's just 10 microfarads, just like all the others. And now this condition is off. So the circuit will be off when we put in a shorting capacitor of the same value as everything else. For all intents and purposes, it will be off. Now these are the node voltages. So when it's off, the node voltages are around the picofarad range and they're all over the place. And there's a reason for that I'm going to show you in a minute. But when it's on, they're ridiculously high accumulated values, gigavolts, you know, megavolts somewhere, kilovolts. Yeah, I don't see any megavolts anywhere, do you? Yeah, no. It's all mostly thousands of volts versus gigavolts. So let's move right along here. Now let's back away. Now this is an off condition, and you end up with a sine wave that's really tiny. It's, wow, a lot less than 50 femto amps. And it's just a sine wave. And it doesn't vary, it doesn't change, doesn't grow, doesn't shrink. And so it shows that the input radio tuner is having its influence and having it say so because there's no energy backwashing out of the core of the circuit to overwhelm that radio tuner with all kinds of drastic levels of energy. So when the variable capacitors C15, C16, and C17 are within the range of the upper and lower boundaries, then this circuit is off for all intents and purposes, humming at a negligible level of energy, exhibiting uniform sine waves. So far, so good. But when it's on, outside that range, such as at 1e to the negative 201, now we've got 220 amps RMS on the 1000 ohm resistive load. And this is all 400 picosecond simulations. So I think that pretty much finishes this stage of the game. I still don't know what would happen if it's rapidly oscillated. What kind of parametric effect would that have on the circuit? Because it's already behaving as a parametric amplification. No need to make it worse and make it explode. The whole point is try to slow this thing down. So I'm not sure this system will work unless when the capacitor is reduced to nearly 0 farads, is there some way of damping out the charge? Or maybe when it's increased, when it's brought back, actually, that's when it happens, right? Well, maybe both times. So there might be a 4-phase cycle to the change of the capacitance, so that in between the lower setting and the higher setting, the capacitor has to be grounded out or shorted to itself or something, so that we don't get parametric amplification in the course of oscillating back and forth between the low state and the high state of capacitance for those 3 capacitors, C15, 16, and 17. All right, that pretty much wraps this up.